Well, welcome back, my chemistry compadres. Today we are going to take a look at some chemical reactions. We'll talk a little bit about the basics of what a chemical reaction looks like, and then we're going to dive into the exciting world of how to balance those chemical reactions to ensure that the amount of reactants that we start with is the same as the amount of products that we end up with in a chemical equation. So a little bit about what you are going to look at today. You should be able to understand how chemical reactions are expressed and written, and then you should also be able to balance and write out full chemical reactions today. A little bit about some of the vocabulary terms that you may see in this video. We'll talk about chemical equations. We'll also talk about the term precipitate. We'll also look at the concepts of coefficients, word equations, formula equations, and a reversible reaction. So a little bit about what are chemical reactions. Well, chemical reactions are the process where we transform the reactants of a chemical equation to the products. Keep in mind that the reactants are what you start with and the products are what you end with. Now, chemical equations use a variety of different symbols and formulas to identify reactants and products within a chemical reaction. So if we take a look at the chemical reaction here on the right, we have a piece of copper wire, and that copper wire is being dipped into a vial of silver nitrate. So as you can see, the silver from the silver nitrate is actually reacting with the copper, producing a blue solution of copper nitrate and silver that exists on the outside of the copper wire. That's what the little fuzzies look like. So this is an example of a chemical reaction where we're taking reactants, which are copper and silver nitrate, and producing two products with that, silver and copper nitrate. So how do we even know that chemical reactions take place? Well, there are a variety of different ways that we can look at a reaction when we mix two chemicals and identify if a reaction has actually taken place. The first is a release of energy as heat or light. So when we react chemicals together, a lot of times they will emit energy. They'll feel warm or they'll feel cold. Sometimes you'll see color changes. As an example, on the right here, we mix two clear chemicals, which results in a color change that is produced. Another one is an evolution of a gas. So a gas may be produced from that. You can maybe be able to see the gas. If you waft very, very gently, you might be able to smell the gas. Or in some cases, we use a splint, which is a little piece of wood, and we ignite that, and then we can actually use that to detect a gas that is present, whether it goes away in the presence of the gas or whether it ignites the gas, something along those lines. And then lastly would be a formation of a precipitate, which is a solid produced that separates from a solution. So when we sometimes mix two solutions together, we actually produce a solid from that, and that solid appears at the bottom of the chemical reaction. So some things to just kind of keep in mind of knowing when and how a chemical reaction might have taken place. So when we write chemical reactions, we need to make sure we follow a few rules. The first rule being the law of conservation of mass must be observed. So in this instance, we actually use coefficients. Those are numbers that occur before the chemicals to balance equations. What's really important here is that the formulas to the equations must be written correctly. So we can't go around changing the formulas of the chemicals because we can't actually change those chemicals. We can't change the formula for them. That's the formula for the chemical. But what we can do is add coefficients in the front in order to balance the equation here. So what has happened down here below is that we have our reactants to the left and our products to the right. And in this instance, nitrogen, which is N2, plus hydrogen, which is H2, produces NH3. Now, without the numbers that are there, we'd have two nitrogen atoms on the left and one on the right, and two hydrogen atoms on the left and three on the right. Well, in order to balance those out, we have to put coefficients in front of the reactants and products in order to ensure that the number of atoms on the left is the same as the number of atoms on the right. So we add a 2 in front of NH3 and a 3 in front of H2, and as a result, we now have 6 atoms of hydrogen on the left and 6 atoms of hydrogen on the right. We also have 2 atoms of nitrogen on the left and 2 on the right, so this formula is balanced. Now keep in mind that chemical equations can be written with both formulas and words. So in this case we have a formula equation, but you may be asked a word equation, in which case you'll need to know your nomenclature in order to write it into the correct formula. So how do we balance our chemical equations? Well, the first thing we need to do is make sure that we write our formulas correctly for reactants and products. That's very important. If we don't write our formulas correctly, we're going to end up with very, very poor balancing skills, and we're not going to be successful in balancing or predicting products of chemical reactions, which occurs later on. So it's really important that you write your formulas correctly. That's why we spent so much time focusing on being successful at nomenclature. Secondly, you should be able to balance your equations until the atoms in the reactants are the same as the atoms in the products. So in this case, we added two coefficients here in order to successfully balance our equation. You notice that we had, if we didn't have the coefficients, we had one copper and one copper. We had one silver on the left, one silver on the right. We had one NO3 on the left and two NO3s on the right. One key I'm going to give you is to make sure to try to keep your polyatomic ions together if you can. So in order to balance the nitrate ion on the right hand side, because there are two of them, we add a coefficient 2 on the front of AgNO3 on the left hand side, thus creating two NO3s on the left and two on the right. But that changed the number of silver atoms on the left. So we have two silvers on the left and one on the right, so we insert a 2 in front of the silver on the right, thus balancing the equation. So now we have one copper on each side, two silvers on each side, and two nitrates on each side. Some important symbols that you may see here: you have your states of matter that are located below this: S for solid, L for liquid, G for gas. Anything that's listed as AQ is something that is dissolved in water. AQ stands for aqueous. A reaction arrow pointing to the right means yields. It indicates the direction or the result of the reaction. In some cases, you have the reaction arrow pointing both ways, which indicates a reversible reaction or potentially a reaction that is at equilibrium. So let's do a couple practice problems of balancing chemical equations. So some instances for you it might be easier to make a chart. For the first couple ones I'll probably do this, but as you actually start getting better with this, you will recognize that you can sometimes just go back and forth between your reactants and products and do this very easily. However you want to do this is fine. So I'm going to start by making what I like to call an RP chart. Okay, R stands for reactants, P stands for products. And I look at my equation and I look at what specific chemicals, elements, or polyatomic ions I might have. So I have carbon, I have hydrogen, and I have oxygen for my first one. So I look on the left-hand side of my reactants and I have one carbon, I have 4 hydrogens, and I have 2 oxygens. I look on my product side, I have one carbon, I have 2 hydrogens, and I have 3 oxygens. So my carbons are good. I can't really balance those. Oxygen 2 and 3 might be a bit complicated, but let's start off by balancing our hydrogens. So we have 4 on the left-hand side and 2 on the right-hand side. Well, in order to balance that out, I need to place a 2 in front of H2O. What that does is that changes the number of hydrogens from 2 to 4. All right? That doesn't change my carbons. It does change my oxygens, though. So instead of having 3 oxygens on the right-hand side, I have 2 and then 2 oxygens here for a total of 4. So I'm almost balanced. If I go back to the right-hand side, I can put a 2 in front of my O2, and what that does is that changes this to 4. So now I have the same number of atoms on the left-hand side and the right-hand side of my chemical equation. And therefore, the equation is completely balanced. Let's look at the one down here at the bottom. Same concept. We'll make a nice little chart here. Reactants and products. I have zinc, I have hydrogen, and I have chlorine. On my reactant side, it looks like I have one of each. One zinc, one hydrogen, and one chlorine. On my product side, I have one zinc, I have 2 hydrogens, and I have 2 chlorines. So if I take a look at this and think about this, I need to adjust the hydrogens and chlorines on the left-hand side. Unfortunately, they're together. So what I notice is that if I put a 2 in front of HCl, that changes these 1s to 2's. And as a result, my equation is balanced. Now again, not all of them are going to be this easy, but hopefully this gives you kind of a basic idea of where to start in terms of balancing chemical equations. So let's take a look at one more practice problem just to make sure we kind of have an idea of what's going on here. Write out the balanced chemical equation for the following. Aluminum sulfide reacts with calcium hydroxide to form aluminum hydroxide and calcium sulfide. So obviously in this equation I have not given you the full equation. You're going to have to figure that out yourself, which means essentially we have 4 nomenclature problems that we are going to have to do. So yes, we need to make sure we're using our periodic table, we understand our charges and oxidation numbers and whatnot. So let's go ahead and write these 4 out, and then we'll put them in an equation. So the first one here, aluminum sulfide. Aluminum is Al. Sulfide is just S. It's plus 3 minus 2. So aluminum sulfide is Al2 S3. Calcium hydroxide, Ca hydroxide, OH, we have plus 2 minus 1. So we do our work here. We're going to get Ca OH 2. Aluminum hydroxide, Al OH 3 and 1. So this is going to be Al OH 3. Calcium sulfide, Ca and S, plus 2 minus 2. So that's just CaS. Okay? So did our 4 nomenclatures. So let's go ahead and write out our equation that's unbalanced. So I'll put little lines in front to kind of help. So we've got aluminum sulfide, Al2 S3 plus CaOH2 yields AlOH3 plus CaS. All right, there we go. So now the process becomes, how do we go through and balance this chemical equation? So we can go ahead and create our RP chart. So we'll do this down here at the bottom. And look at the species that we've got here. We have aluminum, sulfur, calcium, and you notice we have a polyatomic ion here. We have O and H. If you see a polyatomic ion on both sides, you don't have to separate it. You can just balance the polyatomic ions. It actually makes your life a whole lot easier when you go through and do this. So count up the numbers on my reactant side. I have 2 aluminums, 3 sulfurs, 1 calcium, and 2 hydroxides. Product side, I have 1 aluminum, I have 1 sulfur, I have 1 calcium, and I have 3 hydroxides. Okay, so my first advice for you would be to balance the things that are the most complex, meaning typically your polyatomic ions. So let's do that first, and let's see where we end up. So with calcium, with calcium hydroxide and aluminum hydroxide, it's 2 and 3. Well, to balance those out, we need to figure out the lowest common multiple of those, which is going to be 6. So I'm going to put a 3 here and a 2 in front of aluminum. So now our OHs cancel, so we're good there. We have the right number of OHs on each side. Aluminums, we have the right number on each side, 2 and 2. Sulfur is 3 and 1, and calcium is 3 and 1. So we need to think of how we're going to go through and balance these out. Well, I know I need 3 calciums and 3 sulfurs on my right hand side, so fortunately they're together. I can add a 3 in front of CAS, and as a result, these 1s become 3s. And now everything is completely balanced. I have 2 aluminums on the left and on the right, 3 sulfurs on the left and on the right, 3 calciums on the left and on the right, and a total of 6 hydroxides on each side. So this is my balanced chemical equation. Okay? It's a little bit more complex when you have a little bit more work to do, but like I said, keep in your mind that this is a bit of a complex process, and the more practice we get with it, the better off we're going to be. So just a couple of key rules, some LAM rules to follow. I would always start with what looks like is your hardest element to balance, and typically those are things that are going to result in not just like 1s and 2s, but you end up with things like 6s. A lot of times your polyatomic ions are going to be what you want to start with when you balance. It's just going to depend on the situation. This isn't one of those things where there's one set of rules that you're going to follow every single time. It's going to take practice for you to be able to see how to work through this process and then eventually get what you need. Work back and forth between the reactants and the product. So if you change something in the reactants, you put a number in front of one thing to balance something out, that's going to change something else in the reactants as well. And then figure out what numbers you can put in front of your products to balance and kind of work back and forth between your reactants and products in order to balance your chemical equation. Make a chart if you need to do so, like what I did. Use the RP chart if that helps. Keep your polyatomic ions together if you can. That's not always going to be the case, but if you can do that, it's going to make your life a whole lot easier. And if you do get stuck somewhere, just start with a new element. Some of this is trial and error, and some of this is practice that you're going to need to get. And sometimes you are going to make mistakes. But the more you practice with it, the more resilience you have, and the more you do, the more successful you're going to be. So long story short, chemical equations can be written out using words and chemical equations, and they must be balanced with correctly written chemical formulas. So keep in mind that this really is a practice. There's no set rules for it, but the more you do it, the better you're going to be. Hopefully you understand the learning targets for this particular video. I hope you had a great time today. We will practice with this in class, and as always, I'll talk to you later, guys. Have a great day. Bye-bye.